Hello, and welcome to a digital statistics lecture for Salt Lake Community College. In this video, we're going to be talking about section 1.4, other effective sampling methods. Other implying the ones that are different from section 1.3, where we talked about how to conduct a simple random sample. Here, we're going to talk about the other sampling methods that have varying levels of success. Some of them are good, some of them are not so good, and we're going to talk about the different problems that each of them have. Basically, if you do not have a simple random sample, if you have these samples, there's always going to be at least some problem. So we're going to talk about the issues that they have here. Okay. First, a stratified sample. Stratified sample is a simple random sample that is drawn from each non-overlapping subgroup that the population has been separated into, or called strata. All right, now that might be a little confusing. The way this works, say this is my population. Let's make a better circle that doesn't overlap with words. Okay, so this is my population. What I'm going to do with this population is I'm going to split it up into groups. So maybe that's one group. So I'll say group 1. And that's group 2. That's group 3. That's group 4. That's group 5. That's group 6 and group 7 in the middle here. So I split those into 7 groups. And then what I would do is go into each group. So I would then say, let's do red here. I would then say, okay, go into group 3 and take 2 random from group 3. And then go into group 2 and take 2 random from group 2. Then go into group 1 and take 2 random. And I do this for every single group, or strata as they are called. I conduct a simple random sample in every single group. That is a stratified sample. Now, there are good things about this. The main good thing about this is that it can save a lot of money and time. And that's usually the problem with simple random samples, is that taking a simple random sample of the population of the United States is not viable for money, for usually monetary reasons. But when I split up the population, it's a lot easier to manage. For example, an easy way to split up the population as it is right now for the United States is to split it up into the 50 states. And then say, take 5 random individuals from each state. That way, on paper, it sounds like I have a good representation of the population because I'm getting individuals from each area and I'm selecting them randomly. On paper, that looks great. A problem with stratified sample, though, particularly with the example that I just gave, is that those states are not the same size. So, for example, Wyoming has the smallest population in the United States, and I think California has the highest. So when I select 5 individuals from Wyoming and 5 individuals from California, those individuals in Wyoming all have a higher chance of being selected simply because they live in an area with a much smaller population. So Wyoming people would have a much higher chance of being selected than those in California. That's a definite problem with stratified samples, is that very often the non-overlapping subgroups don't necessarily have the same size. If you can get them to have the same size, if the size of the simple random sample is proportional to the number of individuals, so if you can get each strata to be the same size, then this works fine, but there's still problems with it. Note that the description says, though, that they use a simple random sample. You'll notice that as a consistent theme, that a lot of these methods will imply or will apply a simple random sample to some extent, but it's not going to be a pure one. And what that means is that when you look at an example and they use the word random, that does not imply that it is a pure, simple random sample. It could be one of the few pseudo-random, as I call them, which is going to be stratified in the next 2. The next one, systematic sampling, is, let me erase that. Systematic sampling is where you start at some point in a list of individuals, and then you select every kth person after that. So maybe if I take my frame of individuals and I start at the 3rd number and I select every 7th after that. That means I'm going to select the 3rd person, and then the 10th person, and then the 17th person, and then the 24th, and then the 31st, just adding 7 every time. That's how I would select my sample. There's some pseudo-randomness to there because you randomly select a starting point and you select individuals based on how big you want the sample to end up being. But it's not going to be purely random because there's at some stage once you select a starting point that's going to invalidate other people just because they were in a different position. So there are problems with it. But we have an example of it done here. Typically, you decide K based on how big the population is. So take the population, divide by the sample to get how many people you need to select. And then that's how often you'll select individuals. For example, here, it says n is 4, which means the sample size is 4. And you're going to start off with the 5th and then every 8th person after that. So the 5th person is where we start, so 5. That's going to be our starting point. Then to find our second person, we do our starting point and add 8 to that for every 8th person selected. So 5 plus 8. That will give us 13. Then we do 5 plus 2 times 8, or plus 16. That gives us 21. So we add another 8 to that. And then we do that again. So 5 plus 3 times 8. Or just add 8 again to 21 to get 29. That's how we select our individuals. So that's how we would progress through systematic sampling. Note that it still applies randomness a bit because they randomly select a starting point. But after that, it's no longer random. So there's always a little bit of randomness included in the pseudo-random. The last pseudo-random sample is what we call a cluster sample, which is going to be very, very, very similar to a stratified sample. It says the population is divided into sections, which stratified sampling does, and then all individuals from randomly selected clusters are included in the sample. On paper, again, that sounds exactly like stratified, but there is a small difference here. To show that, I'm going to again do a circle and say, here's my population divided into 1, 2, 3, 4, 5, 6, and 7 sections. So 1, 2, 3, 4, 5, 6, and 7 sections. So that's my population split up. And Stratify would do this exact same process too. It just splits up the population. The difference being what happens after that. Remember, Stratified would then go into each of these, and then it would select a simple random sample out of each of these different sections. That is not what Cluster is going to do. Cluster is going to do something a little bit different than that. I'm trying to erase the right pieces here. Okay, erase that. Okay, Cluster is going to do something a little bit different. What Cluster does is it randomly selects clusters or sections and then takes all individuals. Takes all individuals from those sections. So maybe here I randomly select sections 5 and 3. So what that means is that I'm going to go into section 5 and take all the individuals in section 5. And I'm going to go into section 3 and take all the individuals in section 3. That would be an example of cluster sampling. Note that when I draw that, it even looks different than how Stratified does. Stratified, you go into each of them and select people. Cluster, you take whole sections and you take everybody in those sections. This is, again, better because if you section off people like this, it's a lot easier to select geographically. For example, if you do counties in Utah, and I'm trying to select random individuals in Utah and I just select them by counties. That's a lot easier to manage because I can tell researchers to say, hey, get everybody in that county, and that county. And that's all I need. That's a lot easier to do than trying to randomly select 40 individuals or 1,000 individuals in Utah and make sure I get access to them when they're in completely different places. So it's a lot more convenient. However, it's not perfect. Yet again, it still incorporates some bias that we'll get into in 1.5. But just know that it's not horrible. It does employ some randomness to it as well, which does make it pseudo-random. So again, even if you see the word random, doesn't mean it's a pure, simple random sample. Could be one of these. But that's it for our pseudo-random samples: stratified, systematic, and cluster. After that, we have a few other types of samples that are not too good, or sampling methods that aren't too good. First, convenience sampling. It's in the name. The sampling subjects who are easy to get, which is a very, very bad sampling method. This is as if I wanted to study all individuals who are students at Salt Lake Community College. And so what I do is I just take all the individuals in my stats class. They're all students at the college, so they all count as part of the population. However, that's a very specific section of students. There's usually a lot of things that they have in common. For example, the students that take my stats class aren't in certain subject areas. They don't need to go down the line of Math 1050 and 1060, or they don't need to take Math 1030. There tends to be a lot of similarities between those individuals. And that's a huge problem with convenience sampling. When you take a sample that's far too convenient, it's probably a problem. That there's likely too many characteristics in common between those individuals. It's very, very lazy, and as we even have here, it works best when never, don't do it. Even though we say that, it's probably one of the most commonly done, simply because it costs the least amount of money, the least amount of time, and a lot of researchers only have so much of those. So it's regrettable, but you do see it way more often than you would like. A subsection of convenience is what we call voluntary response. And again, it's in the name. If the individual selected have a choice of opting in or out, we call that a voluntary response sample. So maybe you give out a flyer and they have the choice of whether they want to respond to it. Or maybe if you go to, say, Subway or McDonald's or something, and at the bottom of the receipt there is a survey asking for individuals to give their thoughts on the service that they received. Very few people even opt into doing those things, and if they do opt in, there's usually an incentive for that, which can be a problem. Voluntary response is very bad, but it's also very hard to take out. Usually we have to do voluntary response in some way and mix it with things, and that's where we get multi-stage sampling. If you ever mix two sampling methods together or more, we call that a multi-stage. You'll very often see this with voluntary response because since we have ethics, we have to give people an option to opt in or out of a survey. So you'll very often see something like a stratified sample where we randomly select people in different groups, but then they have the choice to take part in a survey or a medical study or whatever we're doing. So that's something to keep in mind, that even though voluntary response and convenience are bad, they're very commonly done, and a lot of it is out of necessity because of ethics. All right, so those are the different sampling methods. There's a lot more than this. There's some called like quota sampling, for example, but these are the ones we're going to address in this class. All right, now we have some examples to help you with this. We have 3 examples specifically. First, an example that has a lot of different situations, and we're going to identify which of the different methods there are. Each of these methods are going to only be used once, so once we use it, we're going to cross it off. Okay, some of these are going to be pretty easy to identify, some not so much. First, the 5th person exiting the student center and every 12th person afterward is interviewed. All right, well that one isn't too bad. It's giving a starting point in how often you select individuals. Those are the hallmarks of systematic sampling. So this is C. So since we've used C, that's off the board. 2 out of the 6 parking lots on campus are randomly selected. Okay, stop right there. 2 out of the 6 parking lots are selected. If we consider parking lots as sections, then that means we're selecting 2 out of the 6 sections. Already, this sounds like either stratified or cluster, or maybe multi-stage. And every driver in the 2 lots receives a questionnaire. Okay, since they're looking at every driver, that means that this is definitely a cluster sample. It would be stratified if I randomly select individuals in each of those lots. But since we're not doing that, this is a cluster sample. So this is D. And so D is off the board. Third, each registered student is assigned a number. 20 numbers are randomly generated, and the corresponding students are interviewed. All right, well, assigning students a number and then selecting 20 numbers at random, that is how a simple random sample is done. That's how we did it in our calculator in section 1.3. We just give people numbers, and we randomly select numbers. I don't see anything else giving us any other points there, so that's a simple random sample. I will also point out that in the previous question, we had up here 2 out of the 6 parking lots are randomly selected. Even though you see the word random, that doesn't mean it's a pure, simple random sample. I harp on that a lot, but a lot of students make that mistake. So be careful. All right, fourth, 6 buildings on campus are randomly selected. So again, this sounds a lot like cluster because they're selecting buildings. So 6 buildings out of however many buildings. And then every 4th person who exits the building is included in the sample. So the 6 buildings on campus being selected, and then every 4th. That sounds like a mix of cluster with the 6 buildings, and 4th makes it sound like systematic. That means that this is multi-stage. It's combining multiple things together. Okay, randomly select 10 males and 10 females in the activity center to be interviewed. Now this sounds like simple random sample because all you see is random and 10 males and 10 females. But what this one actually is stratified. This is B. The reason is because they took the population and they split into 2 groups, males and females. And then they went into each of these groups and selected 10 random from each of the groups. So that means that this is a stratified sample because they went to each group and they randomly selected from each. So that's why this is stratified. All right. Almost done here. Every person in my class that sits next to me, all right, in my class that sits next to me, that's very convenient. They are interviewed. That's super convenient. And lastly, a pile of questionnaires is left on the table in the library with a sign that says, please complete. That is going to be our voluntary response sample, and we are done. All right. With that said, there's one last note I want to make about each of these. In most of these cases, realistically, we would look at them and say, oh, well, they have a chance to respond. The students assigned a number, and then they're interviewed. They have a chance to respond. The randomly selected 10 males and females are interviewed. They have a chance to respond. And same thing with the people that sit next to me in class. They have a chance to respond. So a lot of these people could look at it and say, well, it probably incorporates voluntary response in some way. I will say, unless it explicitly states that they have a choice to respond, like the last one, the pile of questionnaires left on the table with the sign that says, please complete. That last part of it explicitly shows that they have a choice to respond or not. If you do not see anything like that, do not call it voluntary response. You have to see some indication that they had a choice. Don't just assume it. All right. A few more examples here, and these are going to be the same methods we had. But this one, we could have repeated values, and we're going to see if we can figure all these out. First, to estimate the percentage of defects in a recent manufacturing batch, a quality control manager selects every 8th chip that comes off the assembly line, starting with the 3rd, until she have changed 140. I will also say, if you haven't already, pause the video, try these on your own, and see if you can figure them out. Since this one says that they select the every 8th chip, starting with the 3rd, that's numerical way of selecting people. That's a very simple system. This is what we call a systematic sample. So that's a systematic sample. Maybe I'll put it over here. So systematic. All right. So that one's pretty easy to identify. You're always looking for those kind of things. Now, B, to determine customer opinion of its boarding policy, Southwest Airlines randomly selects 60 flights during a certain week and surveys all passengers on those flights. So 60 flights is probably not all the flights that they have in the week, and there's kind of that implication. They randomly selected them, so it's probably not all of them. They randomly selected 60 of the flights, and then they surveyed all passengers on the flights. That indication of looking at every passenger on each of those 60 flights, that makes this a cluster sample. They randomly selected clusters, the clusters being flights in this case, and then they interviewed everybody on those clusters. All right. C. A member of Congress wishes to determine her constituency's opinion regarding estate taxes. She divides her constituency into 3 income classes. So we have the 3 classes, low income, middle, and upper. She then takes a simple random sample of households from each income class. A lot of people would look at this, and some would say, oh wait, it's a simple random sample, so this is an SRS, right? Just says simple random sample there in the description, I'm done. No, this is not a simple random sample. Remember that there are multiple different methods that employ randomness. Since we divided the constituency into 3 classes, we have a group we divided into 3 different classes, and then we randomly selected in each of those classes. This is a stratified sample. If you even look back at the definition of stratified definition even uses the word simple random sample as part of it. All right, letter D. In an effort to identify whether an advertising campaign has been effective, a marketing firm conducts a nationwide poll by randomly selecting individuals from a list of known users of the product. Okay, now this one I could see some contention here. There's not too much given. Some people would say that this is just an SRS because they're randomly selecting individuals from a list, which sounds like an SRS in theory. However, the point of contention that I would say is that it's a list of known users of the product. That is a very convenient list for them to have, that they already have that list down. They don't have a poll of the entire nation, which is what they really want to do. If they're advertising, they want to see how their advertising did, and particularly include those that didn't already use the product. So I would probably argue that this is probably convenient or even multi-stage. So convenience or possibly multi-stage, because it includes convenience and a little bit of randomness there too. So that's what I would probably argue. Some might say that it is just purely random, but there's definitely a problem there with the list of known users. So small thing, but thing to look out for. E. A radio station asks its listeners to call in their opinion regarding the use of U.S. forces in peacekeeping missions. So we're told that they ask the listeners to call in their opinion. That means that they have a choice to respond. This one we'll say is voluntary. So voluntary response for E. And then lastly, a college official divides the student population into 5 classes. So this is so far like the 3 income classes. The official takes a simple random sample from each class and asks members' opinions regarding the student services. So this is, yet again, stratified. It does say that they ask their opinions, but again, there's no indication that they have a choice of responding. If there was an indication that they had a choice, then we would say stratified plus voluntary, so multi-stage. But here, no choice, just split them into classes, take a simple random sample from each. So population, 1, 2, 3, 4, 5, and then go into each of those classes. That's what was done here. All right, so those are some examples of identifying the different type of sampling methods. We have one last example here, and this is how systematic works. All right. The Human Resources Department at a certain company wants to conduct a survey regarding worker morale. The department has a list of all 400 employees at the company and wants to do a systematic sample of size 20. To do this, they randomly select the random number 8 person and then selects every 20th person after that. So we're starting with 8 and we're selecting every 20th after that. List the corresponding workers to be surveyed. All right, well, the first person they say is number 8. It's pretty obvious. The second person, we then take 8 and we add 20 because they want every 20th person after that. So we get 28. With the third person, we then took 8 and we added 2 20s. So I'll say 2 times 20. That gives us 48. You just keep adding 20 every time. Next one would be 68, then 88, then 108, and we keep going. The question here really, though, is what is the 20th person? Now, take a second, see if you can think about what the 20th person would be, or calculate it for a moment. Pause the video if you need to. Try to determine if you can figure out what number the 20th person would be. Now, if you tried this, one of the most common answers I see for this is 408. That answer, however, is incorrect. The reason is we need to pay attention to the pattern here. When we're adding 20s, we're not just going to be adding 20 20s here, really. So we're not just going to be doing 20 times 20 and adding that to 8. If we look at this, we start at 1, and so we did 8 plus 0 20s. We didn't add any 20s. And then when we did the second person, we added a singular 20. Oh, and when we did the third person, we added 2 20s. Therefore, when we would add the fourth person, we would add 3 20s. Fifth person, we would add 4 20s. Likewise here, with the 20th person, we would only add 19 20s. Therefore, we get a number of 388. This also goes by the formula shown on the previous page, and another reason why 408 doesn't work. It says a list of 400 individuals. We don't have a 408th person. We only have individuals listed from 1 to 400. So 408 doesn't even work in that sense. But that's how you want to keep in mind with systematic. The number of the individual that you're looking at, whichever individual order you're looking at, that's one more than the amount of places you add. So, for example, if I'm looking at the 8th person, for example, I would do that by doing, or maybe I'll do 10th person, just make a different number. The 10th person, I would say, all right, take 8 and add, since I'm looking at the 10th, I would add 9 20s. And that's how I'd solve that. That would give me 188. Okay. I hope that helps understanding the different sampling methods. Again, like the previous view, at this point, go ahead and try your hand at the problem set for section 1.4. You should be able to complete most of those. A lot of them will be trying to identify what sampling method. So keep these in mind, maybe even have the notes open, and then eventually try weeding the notes out and trying it on your own if you can recognize the names. But with that said, I hope you have a nice day.